All right, welcome to the deep dive. We've got a really interesting stack of sources you sent in this week,
Mm.
and they all kind of challenge one of the most basic things we think we know about life, which is time itself.
Yeah, our whole concept of a year, which we just anchor to Earth without a second thought.
Exactly. So today we are diving deep into the very strange, very high-speed reality of the planet Mercury.
It's a great topic. It
Hmm.
really forces you to ask, what do we actually mean when we talk about a birthday or even just aging?
And that's our mission, to unpack this one single fact that just, blew my mind from the sources. Get this. If you lived on Mercury, you would celebrate your birthday about 4 times for every single Earth year.
And that's not a metaphor or some kind of thought experiment. That is pure, measurable astrophysics.
A 4-to-1 ratio. It's just astonishing.
It is. And we're going to get into the physics behind that speed. And then this is the really wild part, the paradox of what a day on Mercury actually is.
Okay, let's jump right in then. Segment 1. Mercury, the speed demon. So when we say the year is short, let's just nail down that number. How short are we talking?
The official number for 1 year on Mercury, its orbital period, is just 88 Earth days.
88 days.
Yeah.
That's less than 3 months. I mean, think about that. That's basically one season here on Earth.
Right. And in that time, Mercury's already done a full lap around the sun. It is the absolute sprinter of the solar system.
It really is. So why? What
Mhm.
makes it so incredibly fast? The sources say it's more than just being close to the sun.
That's the key insight, really. Its proximity is part of it, but the real answer is its velocity.
Hmm.
Mercury is, by a long shot, the fastest planet we have.
Okay, so how much faster are we talking? Give us some perspective compared to, our own leisurely trip around the sun.
Well, Earth is cruising along at an average speed of about 30 kilometers per second, which is already fast.
Right.
But Mercury is tearing through space at almost 48 kilometers per second.
Wow. 48 kilometers every single second. That's almost impossible to even picture.
That's a massive difference. We're talking about something moving roughly 60% faster than us.
But, okay, I feel like this brings up another question. If it's that close to the sun and there's all that gravity, shouldn't it just get sucked right in? Why the need for all that speed?
That's the perfect question. It gets right to the heart of orbital mechanics, Kepler's laws specifically.
Hmm.
The sun's gravity is like this giant invisible rope constantly trying to pull Mercury in.
Okay.
But that incredible speed, that 48 kilometers per second, creates enough sideways momentum, enough inertia to constantly miss the sun. It's falling, but it's moving so fast sideways that it just keeps circling.
So the speed is literally survival.
Exactly. It has to move that fast, or it would have been consumed by the sun billions of years ago. It's a
Uh-huh.
perfect high-speed balancing act.
Incredible. So that covers the why. It's a speed demon out of necessity.
And that speed is what gives us that 88-day year.
Okay, so we've got the short year down. Let's move into segment 2, because this
Uh-huh.
is where I think our whole concept of time just completely unravels.
This is where it gets really counterintuitive.
We need to talk about what a day means on Mercury, because we just defined a year as the orbital period, right? The trip around the sun.
Correct. But a day is about rotation, how long it takes for the planet to spin once on its own axis.
Right, and for us on Earth, that's simple. 365 days in a year. One rotation is 24 hours. The numbers make sense together.
Yeah, they're nice and tidy.
So what happens when you try to apply that same logic to Mercury?
Well, Mercury just throws that logic right out the window. Because of the sun's immense gravity, its tidal forces have slowed Mercury's rotation way, way down. It spins incredibly slowly.
Okay, so how slow is slow?
The time it takes to spin just once on its axis, what astronomers call a sidereal day, is about 59 Earth days.
59 days to do one turn.
Yep, almost 2 Earth months for one full rotation.
So, wait a minute. The rotation is 59 days, and the year is 88 days. That's odd, but I can still kind of wrap my head around it.
But that's just the physical rotation.
Yeah.
The sidereal day. What we actually experience is a day, the time from one sunrise to the next sunrise, that's the solar day. And on Mercury, that's a completely different number.
Oh, right, because the planet is moving in its orbit so fast while it's spinning so slowly, the sun's position in the sky would barely move.
Precisely. You've nailed it. By the time it's rotated a bit, it's already moved a huge distance in its orbit. So it has to rotate even more to get the sun back to the same spot.
So what's the final number? How long is a solar day?
If you were standing on Mercury waiting for the sun to come back to the exact same place in the sky, it would take 176 Earth days.
176.
176.
Okay, let me just process that. The year one trip around the sun is 88 days.
Correct.
But the day sunrise to sunrise is 176 days.
That is the central mind-bending paradox of Mercury. A single day is exactly twice as long as an entire year.
So you would have a birthday, then another birthday, all within a single Mercurian day.
Exactly. You'd complete 2 full laps around the sun in the time it takes to experience one cycle of day and night.
That is just. It renders our whole system of timekeeping useless.
Yeah.
A birthday is supposed to be an annual milestone, but you'd be celebrating a new year while it's still, like, Tuesday afternoon.
So the whole system is completely out of sync with what we expect. It's an extreme case of orbital mechanics creating a reality that just defies human intuition.
Okay. This brings us perfectly to segment 3, which is the reality check. We have to bring this back to the original question.
Right, the big one, the listener's question.
If I'm having 4 birthdays for every Earth year, am I physically aging 4 times faster?
Yeah, does my body suddenly start to decay quicker?
Exactly. If I'm 40 on Earth, I'm technically 160 on Mercury. Does that mean anything for my actual physical body?
And the answer, based on everything we know from physics, is a clear and simple no.
Okay. That's a relief.
You do not age physically faster. Mercury is fast, for sure, but nowhere near fast enough for any kind of special relativity to kick in and affect your biology.
So we can relax about the extra wrinkles, but we have to explain why. Why does my body get to ignore the planet's calendar?
Because your body runs on a completely different clock. We're talking about a biological clock, which is driven by things like thermodynamics and entropy, not orbital velocity.
Right. Cellular stuff.
Exactly. The rate your cells divide, the pace of chemical reactions in your body, that's all governed by your DNA, your environment, things like temperature. It has absolutely nothing to do with how fast the rock you're standing on is moving around a star.
So we have 2 totally separate clocks, the astronomical clock, which is the planet's movement, and the biological clock, which is us.
That's the crucial distinction. The speed of a planet's orbit just doesn't have a mechanism to reach in and accelerate the biological programming of an organism. Your body's sense of time would stay the same no matter where you are in the solar system.
So Mercury makes you older, only on paper.
Only on paper. It's a fascinating split between a human definition, a year, is one orbit, and a physical reality.
It really shows how arbitrary our system is. We tie everything, legal ages, retirement, to this one specific orbital period.
And if you step off Earth, that measurement becomes meaningless instantly. The calendar on Mercury is flying by, but the clock inside you is just ticking along at the same steady pace.
It's just wild. You'd be like 160 years old on your birth certificate, but physically you'd just be a regular 40-year-old.
And you'd be celebrating that 160th birthday while you're still waiting for the sun to set from, the day that started 88 Earth days ago.
The absurdity just keeps compounding. This has been a fantastic journey, from a simple fact to a really deep understanding of time itself.
It really requires separating those 3 types of time. The orbital period, that's the 88-day year, the sidereal day, the 59-day physical spin, and the solar day, that marathon, 176-day light cycle.
Once you get those 3, you really get Mercury. So to quickly recap for everyone, Mercury is the fastest planet, moving at a blistering 48 kilometers per second.
Which gives it that super short 88-day year.
But, and this is the crucial paradox, its solar day is a staggering 176 Earth days long, twice the length of its year.
And finally, we landed on the reality that your calendar age would race ahead, but your physical biological age would not change. You're only older on paper, not in reality.
Which leaves us with a final thought for you, the listener, to sort of chew on. We've just seen how Mercury completely shatters our concepts of a day and a year. It makes our whole idea of age feel totally arbitrary. So what other human measurements of time might be just as meaningless when you look at the bigger picture?
That's a great question. I mean, think about our calendars, our 7-day weeks, our months. They're all constructs we built based on the perspective of this one planet.
And they totally fall apart just one planet away.
So how much more arbitrary are they when you zoom out and look at the vastness of the universe? It really is all about perspective.
It is. So the next time you mark a date on the calendar, maybe just remember the speed demon next door, where you can have 2 birthdays before the sun even sets.
It's a humbling thought.
Thanks for joining us on this deep dive into the strange reality of time. Until next time, keep looking up.